Okay, this is the last day of simplifying radical expressions, and this is pretty much taking care of law number 3. Law number 3 says you can't have a radical in the denominator of a fraction. Now that's fine, and we've dealt with that before. The only problem is we haven't dealt with it when the radical in the denominator is an addition or subtraction problem. And its opposite, notice they're the exact same thing. The only change is one's an addition problem, one's a subtraction problem. We call this conjugates. It's kind of like in science how you translate it given the situation. It's kind of the same idea here. We translate to give the situation what's needed. So let's take a look at the first example here. So I have 2 plus the square root of 3 times 2 minus the square root of 3. If you multiply those two things together, check out what happens. I have 2 times 2, and then 2 times the square root of 3, but it's a minus 2 times the square root of 3. 2 times the square root of 3, but now it's positive. And then the square root of 3 times the square root of 3. Here's the key thing. You've got to remember that when you take a radical times itself, you actually end up with just the plain radical. You need to remember that the square root of x squared is just plain x. Square roots and squares cancel each other out. So when I take the square root of 3 times itself, it cancels it out, and I'm left with the radical gone. But now that's a subtraction problem because they have different signs. Well, take a look at what we have here. I have the same thing here, and I have 4 minus 3. Well, 4 minus 3 is 1, and because these both have square roots of 3, I can combine them. But it's negative 2 times the square root of 3 plus positive 2 times the square root of 3. That equals 0. Guess what our big bad answer is? 1. Let's check it out again. Let's see what it does again. So let's do 4 plus the square root of 2 times 4 minus the square root of 2. Let's see what happens when we distribute this. 4 times 4 is 16, minus 4 times the square root of 2, plus 4 times the square root of 2. Looks like it might happen again. And then I have minus the square root of 2 times the square root of 2. Just plain 2. Well, I have minus 4 times the square root of 2 plus 4 times the square root of 2. Guess what? Those cancel out, and I'm left with 16 minus 2. 14. Pretty cool. Do you notice that every time the two middle terms cancel each other out? Is that going to happen every time? Yes. If you're multiplying conjugates, yes, it will happen. So if I have 7 minus the square root of 5, what's its conjugate? Square root of 5. I'm going to want to multiply that by 7 plus the square root of 5. Let's see if it does what it really has been doing this whole time. 7 times 7, 49. Plus 7 times the square root of 5, minus 7 times the square root of 5, and then minus 5. Yep, the middle terms keep canceling out every time. This is just 44. Now, if you're starting to recognize that this is something squared minus something squared, you are right. Do you remember when we did problems like this? You guys told me the answer was x squared minus 16. That's because you did the x squared minus the 4 squared. It is the same thing. If you have the addition problem and subtraction problem, you're going to end up with the 7 squared minus the square root of 5 squared. We ended up with 49 minus 5. So we can go straight to that if you want. Now, the reason that we're doing this is for problems like this. I know. If I have 9 over 2 minus the square root of 3. Now notice I have a radical on the bottom. And before, when I had a radical on the bottom, I just multiplied it by that radical. So I would multiply it by the square root of 3. The only problem is I have a subtraction problem. So you actually have to distribute. Now, I got rid of the radical on the square root of 3, but now I still have a radical square root of 3. This doesn't help me get rid of the radical. Do you know what does help me get rid of the radical? Look at what happened every time we multiplied by the conjugate. We got whole number, beautiful answers. So the only way to get rid of a radical in the bottom, the only way to get radical in the bottom that's part of a sum or a difference, if it's adding or subtracting, the only way to get rid of it is to multiply by its conjugate, 2 plus the square root of 3. So I'm going to take this subtraction problem times the addition problem. You're going to have 4 minus 3 in the denominator. But remember, if you multiply the denominator by 2 plus the square root of 3, you have to multiply the numerator by the same thing as well. 18 plus 9 times the square root of 3. And then I just need to do my 4 minus 3. Plus this, sorry. Plus 9 times the square root of 3 over 1. So my answer is just that. See, I do not have a denominator. Woohoo! I do not have a denominator in my radical anymore. So that's how you get rid of the radical in the denominator if it's an addition and subtraction problem. There's a radical in the denominator of an addition or subtraction problem. We're going to change this one to make it harder, like the last problem on your homework. If this is 5 plus the square root of 3 over 3 minus the square root of 7. Now notice I have a radical in the denominator. Don't worry about the numerator. It's fine. It's the radical in the denominator that's the issue, and it's a subtraction problem. The only way to get rid of a radical in the denominator that's part of a subtraction problem is to multiply by its conjugate, the addition problem. So I'm going to take this subtraction problem times that addition problem, and I get 9 minus 7. Something squared minus something squared. But if I take the bottom times 3 plus the square root of 7, have to multiply the top times 3 plus the square root of 7. Now this is an addition problem times an addition problem. Notice those are not conjugates up in the numerator. This one I do have to distribute. 15 plus 5 times the square root of 7 plus 3 times the square root of 3, and then the square root of 7 times the square root of 7 is the square root of 21. That's a lot of fun in the numerator. Can you simplify any of those? I have the square root of 7, square root of 3, and square root of 21. Well, none of them are the same, so I can't combine them. And the square root of 21 does not divide by any of my perfect squares, so it's simplified. Your answer is honestly plus 3 times the square root of 3 plus the square root of 21 all over 2. And that's your final answer. It's kind of fun, I know, but that's how you get rid of conjugates when it's adding and subtracting. Now this is part conjugates, part not. On the first problem, if you had had something like this with a denominator that does have a radical in it, but it's a multiplication problem, this is when we just need to multiply by the radical, because 2 times the square root of 3 times the square root of 3, well, that's 3. So 2 times 3, the denominator would be 6. That's perfectly fine for us. And then we would simplify our numbers. So you have to be very aware, because about half of this is simplifying radical expressions without conjugates, and half of it are conjugates. It's really split into the two. So that is conjugates.